Okay, this is the last chapter, bending and shear strain in the beam. This is the analyzing part. Bending stress in a beam and some external force or load acting on a beam. The shear force and the bending moment are set up at all sections of the beam. Due to the shear force and bending moment, the beam undergoes certain deformation. The stress induced by bending moment is known as bending stress. Pure bending or simple bending, a length of the beam is subjected to a constant bending moment and no shear forces. Then the stresses will be set up in that length of the beam due to bending moment, and that length of the beam is known as pure bending or simple bending. In this figure, we can see the shear force and bending moment. Then the theory of simple bending. We should consider the important assumptions while designing the beams. So the expressions for bending stress, the neutral axis and the moment of resistance. The neutral axis of any transverse section of the beam is defined as the line of intersection of the neutral layer with the lateral sections and written as NA. Okay, in this figure we can find out the change in deformation. Then the moment of resistance due to the bending of layers above the NA are subjected to compressive stresses, whereas the layer below the neutral axis are subjected to tensile stresses. Due to the stress strain and the layers, the force on the layer at any y from the neutral axis, force on layer is equal to E into y divided by R into dA. Then the moment of this force about the neutral axis is equal to force into y. Therefore, the total moment acting on the section is equal to integrate the value. Okay, bending stresses. Bending equation formula is m divided by I is equal to sigma divided by y is equal to E by R. Bending stresses in the symmetrical section. The neutral axis of the material section line at a distance of dv2 from the outermost layer of the section, where d is the diameter of the depth. The formula will be okay. This is the numerical problem. We can substitute it directly.